Deep learning is a subfield of machine learning that utilizes artificial neural networks, ANNs, with multiple layers to learn from data. It has revolutionized various fields, including computer vision, natural language processing, and speech recognition. 1940s, the birth of neural networks with the introduction of the McCulloch-Pitts neuron model. 1960s, development of perceptrons, a simple type of neural network, and the perceptron learning rule. 1970s, the winter of AI, a period of decline in research interest in neural networks due to theoretical limitations. 1980s, backpropagation algorithm is rediscovered, providing a more effective training method for neural networks. 1990s, development of deep learning architectures such as convolutional neural networks, CNNs, and recurrent neural networks, RNNs. 2000s and beyond, deep learning revolutionizes various fields including computer vision, natural language processing, and speech recognition. The McCulloch-Pitts neuron is a fundamental building block of artificial neural networks. It is a simple and elegant model that captures the basic functionality of a biological neuron. The fundamental building block of artificial neural networks models a biological neuron with a simplified input-output relationship, takes multiple inputs, applies a weighted sum, and produces a binary output based on a threshold function. A multi-layer perceptron, MLP, is a type of artificial neural network that consists of multiple layers of neurons. The first layer is the input layer, and the last layer is the output layer. The intermediate layers are called hidden layers. MLPs are capable of learning complex relationships between input and output data. They are a powerful tool for a variety of machine learning tasks, including classification, regression, and clustering. Representation power is the ability of a neural network to learn and represent complex relationships between inputs and outputs. Multi-layer perceptrons, MLPs, have a strong representation power due to their ability to learn nonlinear relationships. This means that they can effectively capture patterns in data that are not easily represented by linear models. Neural networks, neural network connections, brain-inspired processing, node connections. Each node in a layer is connected to every node in the previous layer, creating a web of information processing units that mimic the neural networks in a brain. However, MLPs had their limitations. They struggled with nonlinear problems, which is where sigmoid neurons came in. These special neurons used a sigmoid function to introduce nonlinearity into the network, making it much more flexible and powerful. A type of neuron that introduces nonlinearity into neural networks applies the sigmoid function, which squashes the input between 0 and 1. Enables MLPs to learn complex decision boundaries. This brings us to the concept of feed-forward neural networks. The idea here is simple. Information moves in only one direction, forward, from the input nodes through the hidden nodes and to the output nodes. Feed-forward neural networks are the most common type of neural network. They are relatively easy to train and are used in a variety of machine learning tasks. A. Neural networks where information flows in one direction, from the input layer to the output layer through hidden layers. B. Typically consist of multiple layers of fully connected neurons. C. Commonly used for a variety of tasks, including image classification and natural language processing. Backpropagation is an algorithm for training artificial neural networks. It is a method for calculating the gradient of the error with respect to the weights of the network. Backpropagation is an iterative algorithm that consists of two phases, the forward phase and the backward phase. In the forward phase, the input data is propagated through the network, and the error is calculated. In the backward phase, the error is propagated backward through the network and the weights are updated. A widely used algorithm for training neural networks. B. Propagates errors backward through the network, adjusting weights to minimize the error between the network's output and the desired output. Backpropagation is a powerful tool for training artificial neural networks. It is a versatile algorithm that can be used to train a wide variety of network architectures. The weights of an artificial neural network are the parameters that are learned during training. The initial values of the weights can have a significant impact on the performance of the network. There are a number of different weight initialization methods that can be used. Some common methods include random initialization, Xavier initialization, and He initialization. The choice of weight initialization method depends on the specific task and the architecture of the network. A. Techniques for setting the initial weights of a neural network. B. Important for preventing problems like vanishing gradients and exploding gradients. C. Common methods include random initialization, Xavier initialization, and He initialization. Batch normalization can improve the stability and performance of deep neural networks. It can also help to reduce overfitting. A technique for normalizing the activations of a neural network's layers. B, reduces internal covariate shift, improving training stability and performance. There are a number of different techniques for representation learning, including autoencoders, generative adversarial networks, GANs, and self-supervised learning. The process of learning meaningful representations of data from raw inputs, often achieved through unsupervised learning techniques, such as autoencoders. Learned representations can be used for various downstream tasks, such as classification and regression. Utilizing graphics processing units, GPUs, to accelerate the training and inference of neural networks. GPUs are highly parallel processors, making them well-suited for the computations involved in deep learning. They allow for the parallel processing of thousands of threads simultaneously, making them ideal for the heavy computational needs of deep learning. See dimensionality reduction techniques for reducing the number of variables in a dataset. Principal component analysis, PCA, identifies the principal components that capture the most variance in the data. Singular value decomposition, SVD, factorizes a matrix into 3 matrices, revealing the underlying structure of the data. In summary, deep learning has come a long way since the invention of the McCulloch-Pitts neuron, evolving through the development of multilayer perceptions, sigmoid neurons, and feed-forward neural networks. It has been refined with techniques like backpropagation and weight initialization methods, and powered by GPU implementation. It's a field that's constantly evolving, and who knows what the future holds. So next time you use a voice assistant, or when your email filters out spam, remember the fascinating journey of deep learning. It's a story of constant evolution, of learning from mistakes, and of pushing the boundaries of what machines can do. Indeed, the future of technology is here, and it's deeply learned.